to the island of Malta. On this island, we have 128 red people, 400 yellow people, and 272 green people. Now, in order to know if our Malta island is in Hardy-Weinberg equilibrium, we have to observe at least 2 generations. If the allele frequencies are the same for both generations, then the population is in Hardy-Weinberg equilibrium. Thankfully, we've already done the math, and our first generation had 1,000 people, with a P allele frequency of 0.6 and a Q allele frequency of 0.4, totaling to 1,000 people. The second population, we had 0.6 and a Q allele again of 0.4. Since these allele frequencies are the same for both generations, then the population is indeed in Hardy-Weinberg equilibrium. 0.36, 0.48, and 0.16 for each of our given populations. Now what we are about to observe is something called directional selection, or positive selection. This is a mode of natural selection in which an extreme phenotype is favored over the other phenotypes, causing the allele frequency to shift over time in the direction of that favored phenotype. On the island of Malta, they have recently been stricken with, oh no, vipers! So the red people see that the green people have developed an immunity to the vipers. So the red people and the yellow people decide that the green people are more fit, therefore they decide to mate with the green people. As we can see here, viper fitness is as follows: 1.0 for the green population, 0.875 for the yellow people, and only 0.5 of the red people. So over time, we see that the allele frequency and the genotypic frequency change to 0.42 for the green people, 0.49 for the yellow people, and 0.09 for the red people. For the red people have decreased in frequency. We also saw changes in our allele frequency before and after selection. Allele's frequency for H being 0.6 and for that of little h being 0.4, and then post-selection, 0.665 for big H, and allele frequency of 0.335, a decrease for little h. And now we can see the after effects of selection. The red population is dwindling, the yellow population increasing in number, and the green population also increasing in number, as the vipers still are present on the island. Over time, we can predict that the red population will soon dissolve, yellow and green populations increasing, and eventually, the island of Malta will look like this.